Diana has available 440 yards of fencing and wishes to enclose a rectangular area. Express the area of the rectangle as a function of the width of the rectangle. For what value of W is the area the largest? What is the maximum area? So, since Diana wants to enclose a rectangular area, a rectangle has a length and a width, and the area of the rectangle can be calculated by length times width. Now, it seems like we're almost there, but we want to find the area as a function of width. Right now, we have area as a function of length and width. So what we need to do is we need to use this 440 yards to try to get rid of this variable of length in our function. So the 440 yards is the fencing, and the fencing will go around that rectangular region. And that fencing refers to the perimeter. So the perimeter of a rectangle is 2 times the length plus 2 times the width. So we're going to use all of that 440 yards of fencing. So I'll substitute 440 in for perimeter. And now I can solve this equation for the length so that I can get rid of that variable in the equation. So I'm going to solve for length by subtracting 2w on both sides. That gives me 2l equals 440 minus 2w. I'll divide both sides by 2, and that gives me a length of 220 minus w. So now we're going to be able to answer that part A. We said that the area of the rectangle is length times width, and now that I know that the length is 220 minus the width, I can substitute that in. And simplify a little bit, I've got 220w minus w squared. So now you can see that I have an area function whose only variable is w, which is width. So that is the answer to part A. And in part B, we want to find what value of w is the largest area. So this is kind of an optimization question, finding the largest in this case, but optimization is also finding the smallest in some cases. So what we know about this example is that our function a equals, I'm going to rearrange it a little bit, negative w squared plus 220w is a quadratic. And the graph of a quadratic is a parabola. This particular parabola has a negative leading coefficient, so it's going to be a down-facing parabola. So this is going to be the graph of the area function, a quadratic, and the highest area is going to occur at the vertex. So if we want to find the largest area, we need to find out what the value of that vertex is. We have a formula for calculating the vertex. We can find h by calculating negative b over 2a. That's negative 220 divided by 2 times negative 1. It's negative 220 divided by negative 2, and that's 110. Then we find the y part of the vertex. by substituting that 110 into the area function. It's going to be negative 110 squared plus 220 times 110. Okay, so we're going to type that in our calculator. Negative 110 squared plus 220 times 110. And I get 12,100. Now just to pay attention, we've got two numbers here for the h and for the k. We want to make sure we know what those numbers mean. Typically in an ordered pair, HK, the H stands for the X and the K stands for the Y. In our equation, we don't have X and Y. We have A for the Y part and W for the X part. So for the width, we get 110, that would be yards, and that is our H. And for the area, we get 12,100. That would be yards, square yards, and that's our K. So to answer the question, this is for part B and C, for what value of W is the area the largest? The area will be the largest when the width is 110 yards. And then for part C, what is the maximum area or the largest area? The largest area will be 12,100 square yards. Thank you for checking out my videos. Have a great day.